Here we have a problem on integration. That is, we have to evaluate the given integral. Okay, here we have to integrate the function that is x to the x to the power times 1 positive ln x. It is natural logarithm of x. Okay, already I know the derivative of x to the x to the power. So the derivative of x to the x to the power is x to the x to the power times 1 positive natural logarithm of x. Then what is the integration of x to the x to the power times 1 positive natural logarithm of x? So that is x to the x to the power. So the result of this integration is just x to the x to the power positive the integral constant c. Okay, since I know the derivative of x to the x to the power, I can get the integration of this function in just one step. Okay, what if I do not know the derivative of x to the x to the power that is equals to x to the x to the power times 1 positive natural logarithm of x? So how do we have to integrate this function? Okay, let's look at that stuff. Okay, so here in the given function, so this part, a particular part is little tricky because here we have x, I mean we have variable at the base and we have variable at the exponent. So this part is little tricky. So if I get rid of this part, I think I'll be able to get integration of this function. So how can I get rid of this particular part in the given function? So I have to substitute some new variable for this particular part to get off x to the x power. So that is I'm going to use the method of substitution. So I'm going to substitute a new variable for this particular part x to the x power. So let t equals to x to the x power. Okay, now I have to change the complete integration to the new variable t. So the original integration is in the variable x. Now I have to change the complete integration to the new variable t. So here, since I have this function in the variable x, we integrate this function with respect to x. But when I change the complete integration to the new variable t, so I must have dt over here. That means I have to do integration with respect to dt. Okay, instead of dx, if I want to get dt over here, what should I do? Already I know that already I know what is t equals to. T equals to x to x power. So if I want to get dt, I have to find derivative of this t. So now t actually is a function of x. So I have to find derivative on both sides with respect to x. But before that, we have to consider one more thing. Here we have variable at the exponent. So when I find derivative of a function where we have variable at the exponent, we have to use logarithmic derivative. So that is before we find derivative, we have to take natural logarithm on both sides, and we have to apply the properties of logarithm, and then we have to proceed with proceed derivative process. Okay, now let me take natural logarithm on both sides. The natural logarithm of t equals to natural logarithm of x to the x to power, and natural logarithm of t equals to here the argument of this natural logarithm is exponential, and using the power of logarithm, the exponent of the argument over here can be moved in front of the logarithm, and it has to be multiplied by the logarithm. This is a power rule of logarithm. The next step, it will be x times ln x. Okay, that's all we can use properties of logarithm over here. Only one property, that is power of logarithm. Okay, now we can find I mean we can differentiate both sides with respect to x. Okay, so when I find the derivative of natural logarithm of t, it will be 1 over t. Okay, so far I got derivative only for the natural logarithm. So by chain rule, I have to do further derivative of the argument t with respect to x. It's nothing but dt over dx equals to here we have x, here we have ln x. Both of them are multiplied, and both the terms are contain variable. So whenever two terms are multiplied and both the terms contain variable, and I want to find derivative of that one, I have to use the product rule. So product rule means I have to consider the first term as u and the second term as v. So what I need to do is first I have to find the I have to keep the u as it is. It is x to be kept as it is. So find the derivative of v, that is the derivative of ln x positive. Now I have to find the derivative of u, and I have to keep this v as it is. So we get 1 over t times dt over dx equals to x times. So the derivative of ln x with respect to x is just 1 over x positive. So the derivative of this x is just the derivative of x with respect to x is just 1 times ln x. So this x will cancel out. I get 1 over t times dt over dx equals to 1 positive ln x. Okay, now I'm going to multiply both sides by t times dx. Okay, here the t will cancel, dx will cancel. So finally, I'm getting dt equals to t times 1 plus ln x. I am writing this dx at last. Okay, so here, what do I know for t? So I have assumed t equals to x to the x power. So t can be replaced by this stuff x to the x power, because along with dx we must have only the terms which contain x. So we have to replace this t by the stuff which contains x. So t equals to x to the x power. So we can plug in x to the x power for this t over here. So then we get dt equals to x to the x power times 1 positive ln x times dx. Okay, finally I got the stuff dt. Okay, now so what I need to do is I have to find the integration of this one. So equals to integral. Okay, for this stuff x to the x power times 1 positive ln x dx. What do we know? So here, whatever stuff we have over here, the same we have here. So that is equal to dt. So the path which I circled over here can be replaced by dt because that is equal to dt. So we get integral dt. So the integration of dt is just t, and we have to add integral constant first to c. And what do we know for t? So t equals to x to the x power. So we can plug in x to the x power for t. So x to the x power positive c. Okay, now I got the integration of the given function. So the integration of the given function equals to x to the x power positive c.